كله في اليوتيوب ترى.
ملحوس.
وين الشايب زباله يعني
مو
والله.
Usually we have one down. So on a day that it's not leading right now, and you do want to cycle
Yeah.
them, right?
Yeah.
You
want
want
to keep this always
exactly,
working.
so they're kind of wear at the same time.
Yeah.
So this is leader one, that's leader, and then these two would be secondary. The railroads going down, but there is controls that allows them to run simultaneously, and it's probably somewhere. If you look on the curve, it's probably somewhere around 75%. You bring your other one on, drop that one to 50, and this one to 25. You know, we're probably getting on like your turn down. You're probably pretty close to like minimum right here.
Mm-hmm.
Are those controlled by this building or just?
No, this is based on signals like calls for heat.
And is it automated or
Yes,
is it?
this is 100% automated. I'm sure Kirby can probably bring you over and show you more than I know about this, but this has history in it. And I think 5% of your load, and then as you get more motors, you can start to deduct, right? Like it's a curve. Then you have drives that actually drive it and pare it down, but it's never really 125%, and it's really never that low. So electrical systems are usually beefed up greater than
In the design?
yeah, because the NEC.
Because sometimes design they wouldn't be what actually has been
Correct.
as far as price.
That's true.
But we go for something else.
Yeah.
So the design is for the maximum operation.
For NEC and electric codes, yeah. So there's certain. That's where it gets tricky. That's where all of this like starts to come together for you. Is you can't really look at panel schedules or electrical loads off the drawings. You're going to want to look at if they did an energy analysis. You're going to want. That's really where you should start. So that would be they cycled it through. So most of the time an HVAC calculation should have it. And I'll see if I don't think I have those, but we can ask. But that's going to run through a simulation, right? Like are you familiar with Carrier? They run what's called a HAP calculation, and it takes historical data based on temperatures, and it runs it through this program, and it gives you like your demand days, but then it gives you historical data above that, and it's based on area. So it's realistic to what you should expect.
So it's kind of a comparison between a theory.
Yeah, it's more of a simulation as opposed to like theory.
Does Jeff have
I doubt anybody here has that, because that's really what happens in the design side. So when they're sizing the equipment, you know, you can't. They design for design days and based on the simulation, not the worst case scenarios. If that makes sense. So there's some days like no matter what safeties you put in place for your design, this equipment will never work. That is another thing that like the fan arrays have helped, because then we can really push that volume up, but then you run into other issues, right? Can your coils handle that much heat? Can your coils handle that much heat so you run them longer? What ends up happening in like what Jeff normally does, if we see a long snap coming, he won't take his night setbacks in order to meet your load. So if you don't let your building come down and get cold, you don't have that delta to heat it back up. You're just kind of rounding off that curve right on the bottom side, if that makes sense. So at some point, function has to outweigh energy savings, right? And that's like the key. Yes, but when the 99% are not those. So let's save our energy there, and we understand that it's going to happen in those key areas where you're on your peak days, where it's going to be really hot or really cold. Does that make sense?
Yeah.
Otherwise, you're running your equipment all the time. You know, you've been at your house, like the furnace runs the whole time, like it never stops.
Yes. Yeah.
And so think about if you weren't at home at night and you said, I'm going to turn this off and I'm going to let it go to 50 degrees. And then the next day was that day that it runs all the time. It'll never catch up. It's going to continue to run and run and run and run and run. So what can you do? You can drop your temperature or not take out the bottom half and not set it back. Does that make sense?
But everything bring itself. I mean,
Yeah. Yes. But I think this will be interesting. This will be fun for all of us. Yeah.
Elaine suggested this building because we already have everything that we need to have. Because I think Charlie, there's no architectural energy system for that. Because
Probably
it was
not.
constructed in 1962.
Yeah. And that didn't exist then, right?
Yeah.
Yeah, this was designed to be efficient.
Yeah.
Minus the glass.
Well, we put it into the test.
Yeah, yeah, that'd be awesome. I can't wait. I mean, so glass, no matter what. So in glass, you have to get thermal broken glass, right? Which most of them are. But no matter what, go on a cold day, go on a 5-degree day, and find the best window you can and touch the frame. It's going to be cold, right? And if you take a gun to those, I've done it. They're still 40 degrees. You know, on the best windows. You just can't stop it.
when is it? I mean, is it worth making large windows just for some light?
Is it what worth? Is it worth?
Is it worth making large windows just for some light?
It's aesthetics, right? If you let here's the joke, right? If you let architects do it, let the engineers get involved, right? And like you'll solve the problem, but it may be a box.
I mean, they should do it because we don't have that sense.
Right. Exactly.
Yeah.
So the answer is who knows? It depends on what your client is looking for. This client wants glass, so there's trade-offs on the other side. It's not going to be as efficient as it could be. But that's the beauty of engineering and architecture, right? Like that's your value.
How do you
Right. And that's probably okay. I mean, the principles are there. It's just a bit of a gimmick. I like Energy Star much better because it's not really gimmicky. Yeah. You'll fit right in. Yeah, whatever we can help you with, let me know.
I have one last question.
Okay.
Is there anything here supposed to be on by itself? Other than those boilers?
I mean, but that's designed that way too, right?
Yeah. Something that was designed to work, but it's not working like that.
This is, yeah, I want you to figure this one out. Because I told Jeff about it. There's a magnet helic over here. This is going to challenge you. As you're looking through the drawing, see if you can find out what this is supposed to be doing. Because this was hooked up at one point. And it's not.
Do you know who booked it up?
The contractor that built the building. There was a little compressor with it, but I don't know what it's really for. Like this is a differential, right? That's what generally this is a difference between here and there.
Yes. And what does it
Generally.
What does it connect to?
So that's air handler 4 supply. And I don't know, and this is for in here. I just don't know why this is here. Challenge, huh?
We would look into it.
Alright. But that's really it. Actually, let's go, there's one more thing I want to show you. We'll go that way, it's the elevator. So there's underfloor heating here. I'm running out of time. Long-winded, huh? I mean, someone's following how much it runs. So you might be able to tell by the pump and the speed.
How
Maybe
do
you
you
get
know
a speed
someone's
reference.
following? Because it's a
Because so this is going back to the head end unit of ALC somewhere, right? Which IntelliWeb, ALC and IntelliWeb are, like IntelliWeb is the master version of ALC.
So I wanted to show you this. There are, I think we can access the drawings on this, but I don't think we can access this kind of information.
Okay.
So let's see, Heritage Hall. Takes me some time to find
No
them
worries
because
at
all
all.
of the buildings.
Yeah. My interface is slightly different than yours.
This one. So we have here CHW, which is off now. It's
Yep.
one of the things that we have a work order on. And then we have the, I think this is a main building and then the water treatment.
See, I have a different interface. You have more of the data side, the
Yes.
metering and data side.
I think when I go to navigation and then I write Hcom, I have the living center, heritage. So we kind of have, I don't know how to use this still,
Mm-hmm.
but when Elaine shows me, you can see the set points on these.
Yep.
And I think it's on the graphics, the one that shows you these are all the set points that has in this building.
Okay.
So here's why we can check.
Yeah, I can't see all this.
And then this is HCOM, which is Heritage Hall. And then we look at the main. We can look at the cooling system.
Yeah. See, I can get to roughly here. There's your radiant floor heat. So if you can you see if you can see that one?
I don't think I have access on that. I think Elaine has access on that, but she always can open for me, and I can go look at it and to get the data.
Yeah.
And I have this. So this is the ventilation system that goes in.
Yes.
This is the underground one.
It shouldn't. This should still be above. This is still air handling.
Oh, so it's in the main, the one. I'll ask Elaine about the other one.
Yeah, it should be the radiant floor on that tab. So if you
Okay.
go back one,
When I tried to click on it, it
Yeah.
didn't.
but
Now
that is what this is. That
the
one.
radiant.
Yeah. So that's the one you're gonna want for this.
Nice.
And then there should be. You want the boilers too.
And then there's the domestic hot water too.
Yeah.
So even if I didn't have access to it, I know it's being metered, so I
Yes.
can access those data
Yes.
or request it at least.
Yes. And then where did you all park? We can walk back. I'll show you one more thing.
We came from the Arc, so it's really
Okay.
close.
So
The
just the
engine-
last question.
Yes.
This doesn't show the temperature,
I know. So it's all through here.
but it shows the flow.
It does. Yes. When this, I haven't pushed buttons. I haven't pushed buttons. You might be able to get temperature out of here though.
Well, we know it's
Might.
metered.
I don't know.
in
Yeah.
This, so we can ask for that.
I just haven't touched them. I tried.
Something
I
to-
bumped them one time and I ran. I reset it and ran.
Thank you.
You're welcome.
Has it? Then you should be able to. There should be a way that you can see it somewhere.
I know that from what Elaine showed me, we can see the temperature set points at
Okay.
types. But
Yeah.
for this kind of boiler that is 100% elevated, I don't think, because it's not an IntelliWeb itself, because it's
Right.
providing hot heat
Right.
and water. We have
Yes.
CHW only natural gas and electricity.
Yes.
That's what we have.
And I don't know why it wasn't tied in. I really don't. The heating should be treated, have chemicals and such in it so that it doesn't corrode piping. This is truly just drinking water. You know, it comes out for washing your hands, or showers, but you should be able to consume it.
And you make your own
Yeah,
domestic hot water.
yes. Yeah, it's separate. So what you saw at the heat exchanger, at Shively, was they would produce steam, and they would use that maybe.
The steam wasn't even produced there. It comes from a plant.
Right.
They don't have their own boiler.
And so the steam comes in, and it might hit an exchanger that changes it to hot water.
Yes.
But in that exchanger too, they will run tubes of,
Condensate.
yeah, or they will run like domestic water through it, but it's a separate,
Yeah.
it's a separate feed, right? So you never intermix them, but you can use usually there's a hot water, a heat exchanger and a domestic hot water exchanger that you never even intermix the two. And here we just do it with gas. And that came from really an energy push. Have you heard the name Joel Batens? He was here for, he kind of did what Elaine is doing now. Joel did it 5-6 years ago, maybe less, maybe even 3 years ago. But that was kind of one of his pushes. The reason those gas-fired hot water boilers are upstairs is because of him, and kind of same here.
So is it like a problem that
They're-
three different?
No, the reason that it was done that way is greenhouse gases. This gas is supposed to be more efficient, right? And emit less greenhouse gases than like the steam plant and the inefficiencies of the steam. That's why. That was the push. To me, the steam plant still runs off gas.
Yeah.
You know, I don't buy into kind of all the things. When it was coal, fine. Because in the last 10 years, maybe around 10 years, this was coal-fired plant.
I heard about that.
Yeah.
And then they recently changed that.
Yeah,
It's not
to
that
gas.
far. Yeah.
So, I don't know if you ever run across, but Brody Bowers, he still works here. He actually brought the gas line and it came under the river and into here.
What does he?
He's a project manager in design and construction. There's some cool people around here with some cool stuff. Like, you just gotta know the right people to talk to. There's some really smart people that live on this campus.
Or you're just going to today?
Oh, not me. I'm not saying me. I'm not saying me.
I'm saying.
Oh, thank you. I appreciate that. But there's a lot of knowledge, and as you guys, you know, Ohio alum, as you start to get into that, don't be afraid to ask for resources when you're looking for jobs. Don't be afraid to send, like, to me or Elaine or whoever you meet along this process. Don't be afraid to send them your resume and say, send these to the people you know, because that's like, well, that's what I'm here for. You know,
Thank you.
No worries. That I would want the same thing.
Yes, true.
Yeah, everybody has to start somewhere. And there's a lot of people with some connections, depending on what you want to go into.
And networking gets you halfway.
Yeah, and especially if you've done something like this. Like this is meaningful. Like this is real work. This isn't sitting taking a test.
Yes. That's
You know,
The
this
way we chose this, I was working with Elaine before, and I was telling her I wanted to learn about new stuff and everything, and she proposed ECM, the measurement and verification at ECM, and I asked her how long would it take to learn this, and she said about 5 to 3 months to do it, to learn it and actually do it in practical
Yep.
life. So then I told her I might do it as a senior design project, and then we made it happen.
good. I'm excited for it because again, I think it's important. And what better? We have a building right here. We have resources. You actually want to do something with. I mean, even if we decide we're better or worse or whatever comes out, or hopefully we're worse, so you can come up with some solutions. You know what I mean? I'm not sure they'll ever get done, but I can use those, right? I can take those back to my bosses and say, here are projects for us. Here are the things we need to do moving forward, right? And that is, you're running.
I gotta go.
Okay, bye.
Nice meeting you
We're still
guys.
behind you. I'm right behind you.
Don't forget Jack.
I know. I gotta go get him.